also there are other calculations we have to check, then click the next button. When we click the next button, this calculator section will become here. Also, depending on standard, Indian standard, permissible speed of a small sprocket or pinion in RPM can be categorized in a table. Here there are some parameters. These parameters are type of chain, it may be bush roller chain or silent chain. Also, number of teeth on a sprocket pinion, and also pitch of chain. Here, let us see in the calculator types of chain. It may be what? A silent chain or bush roller chain. Also, number of teeth. Here, number of teeth. We can select from it. Let's see 15, and pitch of chain. Pitch of chain. Let's see 12. Then calculate the RPM. Do you see? Type of chain, bush roller. Number of teeth on the sprocket 15, and pitch of the chain 12. Then the RPM becomes 2200. When we change this value into 30, also the RPM becomes 23. Do you see here? If we change this into 27, calculate the value. This means that here, do you see this? Yeah, the value becomes 1100. And when we change this into, do you see silent chain, we cannot calculate because these parameters are not the correct parameters. So I have to change into the correct parameters, 17 up to 35, this, and then calculate the value. Here we can see the values. Do you see here? 1300 at 30 pitch, and a number of teeth from 70 to 35, and the type of chain is silent chain. This is a calculator which shows this table. Also, there is another table which is the power rating in kilowatt. Do you see this? The power rating in kilowatt of a simple roller chain. In a roller chain there are what? Power ratings. In this table there are also two basic parameters. The first one is the ISO number, of chain, and the second one is what? Do you see the speed of the smaller sprocket? The speed of the smaller sprocket is the ISO number. Then we can get the value of power in kilowatt. Here, let's take these values. For example, at a speed of 200, this means what? Here, and at ISO number 06, then the value becomes 0.47 kilowatt. Here, 0.47 kilowatt. If we change this value into 2000, the value also changes. Do you see here? Yeah. 3.8. Then if we change this into 16, it cannot display any value. It shows only the previous value because in the table there is no value in the table. So let us change into 12. Yeah, do you see here? So this calculator can calculate what? These values or the table value. The other also here we have seen the standard table summarized as follows, or also we can calculate the values. We can calculate what? The values by inputting what? Different parameters. Here, do you see here? The power transmitted by the chain on the basis of breaking load is given by P, which is equals to WB times V over N times KS. This is on the basis of what? Breaking load. Then, by entering the values on this For example, 1000 breaking load, then V, let us give the value V 3 meter per second, and or the factor of safety, for example 4, and the value of case, this case here, for example 2. Then calculate P. Calculate P on the basis of what? WB. You see? WB. Then calculate the power becomes 375 watts here. It is this on the basis of WB. Then also we can calculate the power on the basis of what? Bearing stress. Do you see here? The bearing stress of a material. Then we have to enter the value of bearing stress, for example 500 Newton per millimeter square or megapascal. Then the area in millimeter square, for example 45 millimeter square, and V here, there is a value, and case here is the value. So we can calculate P on the basis of what? Bearing stress. Do you see the value already changed? The value becomes changed. The value becomes changed. These are the calculations we have to done to calculate the power rating of what? The chain drive. Also here there is a table, the standard number of teeth on the smaller sprocket. These are standards or the table given to calculate or to know number of teeth on what? The smaller sprocket. Here the type of chain, roller or silent, is one parameter. The other is what? Number of teeth on the velocity ratio, or the velocity ratio is the another parameter. Here we can select the type of chain. It may be roller chain or it may be silent chain, and then also select the velocity ratio here. Do you see? These are the values of the velocity ratio. Then calculate number of teeth. We have click number of teeth at a velocity ratio of 5 becomes 23. Do you see this? Do you see this? You see this value? This value means that the number of teeth of the smaller sprocket when a type of chain is silent and the velocity ratio is 5. These are the second section of my chain drive calculator. Next we will see the next section of my sprocket calculator. Thank you for that. And here there is the third section of my chain drive calculator, and in this section we can calculate the principal dimensions of the chain and principal dimensions of tooth profiles. Can calculate this section. Here there are the designation of these sprockets and the chain drive. Here the first one is tooth flank radius, or RE, can be calculated as 0.008 times d1 times t squared plus 180. This is the maximum value, and 0.12 d1 times t plus 2 is the minimum value. So we have to calculate R. Then we have to enter the values of d1 or the roller diameter. Let us enter 12 millimeter, and t, it is the number of teeth of the sprocket. Let's take it as 25. Then we can calculate what? RE, or the flank radius, RE. You see the maximum value of RE is 77.8, and the minimum value is around 38.82. Then we can also calculate the roller sitting radius, or RI. The roller sitting radius, or RI. RI is equals to 0.505 d1 plus 0.0069 d1. This is the maximum value, and this is the minimum value, 0.505 d1. So we can calculate the roller seating radius, or RI. The roller seating radius, or RI, here. You see, the minimum value is 6.06 and the maximum value is 6.18 millimeter. The third section, we can calculate the roller seating angle, or alpha. Here, alpha, which is equals to 140 degree minus 90 degree over t. This is the maximum value, and 120 degree minus 90 over t. This is the minimum value. That we can calculate the angle alpha, because the value of t is already fit here, so we can calculate. So roller seating angle alpha becomes 116.4, the minimum value, 136.4. This is the maximum value. Then the other thing where we can calculate in this calculator is tooth height above the pitch polygon, or HA. Do you see? HA, or tooth height above the pitch polygon, HA. We can calculate this. Here, the equation is 0.625p minus 0.5d1 plus 0.8p over t. This is the equation for the maximum value of HA, and 0.5 into p minus d1. This is the minimum value for HA. Now we must enter the value of p. The value of p, pitch of chain, becomes, for example, 7 millimeter. Then we can calculate HA. Do you see? HA, the minimum value minus 2.5 and the maximum value minus 1.41. The negative sign is present because we enter the values arbitrarily or randomly. When we enter the exact values, this value may not be negative, So we will enter the values where we design or generate the exact values. Then the fifth section we can calculate in this calculator is a pitch circle diameter D. The pitch circle diameter D, we have discussed earlier in section 1 of this calculator, but we can also calculate here the pitch circle diameter of a sprocket can be calculated as p times cosec 180 over t. Here we have the value of p, and also we have the value of t, so we can calculate t. You see, the value of the pitch circle diameter of the sprocket becomes 55.855 millimeter. In this value, there is the top diameter dr, the top diameter of the sprocket. The maximum value of the top diameter of the sprocket becomes a pitch circle diameter plus 1.5p minus d1. So we have the value of d here. Also we have the value p, and also we have the value d1 here. So we can calculate what? dA, the top diameter. Top diameter or dA, we can calculate it. What dA and dA here. Yeah, dA. Here the minimum value is 50.403 and the maximum value 50.60, depending on these input values. The other section we can calculate here is the root diameter or dF, which is equals to the pitch circle diameter minus 2r1 times r. Then dF, this, yeah. The value of dF or root diameter becomes this value. Also we can calculate the tooth width or BF1. BF1 means the tooth width here. Do you see this? The tooth width we can calculate here. Let's calculate BF1. BF1 becomes 0.971 when P less than or equal to 0.7 millimeter. And BF1 equals 0.95 B1 when P is equals to 10.7. Here we have entered the value of P as 7, then the formula must be this 0.97 times B times B1. It should be 1. It should be B1 here. B1 is, let's see, B1, we have to enter the value here, yeah, the width between inner plate of chains. We have earlier seen this value on the table, so we have to enter the values here. For example, I would like to enter 3 and then calculate BF1. I have entered the value of B1 and I have already entered the value of P, so I can calculate BF1. Do you see here? The value of BF1 becomes 2.79. For example, I would like to enter this 12, then BF1 becomes similar because BF1 is calculated on the basis of this range or on the basis of this range. If P less than or equal to 12.7, the value is constant. Or still, if the value is greater than 12.7, this value will be changed. For example, let us take it as 13 and calculate BF1. Do you see? The values are changed. So if the value is more and more greater than 12.7, the value is always 2.87. For example, we have like to enter 600, the value becomes what? Remains constant. Then the next thing we can calculate in this calculator is two-side radius or Rx. Then Rx is equals to P. Rx, two-side radius Rx becomes what? P. When we change this P around 45, then also Rx becomes 45 because the equation is this. The other is two-side relief or BA becomes 0.1 P to 0.15 P. In this case, I have used the average value of 0.1 and 0.15. It is around 0.125. I have used it around 0.125. Then times P here. BA, calculate BA 5.65. 0.125 times P. Then width over T BF2 and BF7. Here BF2 and BF7. Then calculate BF2. Then this becomes the number of strands minus 1. We can times BF1. Then we have to enter the number of strands. It may be simplexes, it may be duplex, it may be triplex. So we have to enter what? The number of strands, and we have to enter PT or the transfer speed. And these values also discussed earlier, and the values are given on the table, in the previous table. So let us enter the value around 6, then I can calculate benefit. So the benefit will become 8.85. This is the last video of my chain drive calculator. So if you see this video and this application are helpful for your day-to-day applications, or if you are a student for view design purpose, subscribe my email, my YouTube channel, and I will send this application to you by via email or Telegram or any other means. You can get this application free. So thank you.